Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. It is factoring using the greatest common factor. The first few problems here are review of the distributive property, just so that we can remember exactly what we do for the distributive property. I'm going to go ahead and take my 2, multiply it by the 3x, then take my 2, multiply it by the negative 5. 2 times 3x is 6x. 2 times negative 5 would be negative 10. Okay? 3x times my 2x and 3x times my negative 4, this would be 6x squared minus 4, that'd be 6x squared minus 12x. Anytime I multiply two x's by each other, it would turn into x squared. Whenever I multiply like 3x times a number, then I'll just bring my x along. The next one, I'm going to go ahead and take my 5 times my 3x squared, my 5 times my negative 4x, and my 5 times my 3. 5 times 3x squared would be 15x squared. 5 times negative 4x would be negative 20x, and 5 times 3 would be positive 15. Alright, last one here, we have 4x times 2x squared, 4x times 3x, and 4x times negative 1. 4x times 2x squared would get me 8x to the third. 4x times 3x would be positive 12x squared, and 4x times negative 1 would get me negative 4x. That is just a little review of the distributive property and how distribution does work. On to what our lesson is truly about, which is the greatest common factor. The greatest common factor is the largest number or the largest multiple of the numbers that we are looking at. So in problem number 1, I have 7b minus 7. What I want to do here is figure out what are my multiples of 7b. There's only one way to multiply to 7, that is 7 times 1. I need to multiply by b as well because there is a b there. Okay. Now I have the number 7 again. So that would also be 7 times 1. What I'm going to do then is I'm going to circle the multiples that they share. So 7 and 1. I'm going to take that over here. I would do 7 times 1. If they share the number, I'm only going to write it down once where my GCF is. So 7 times 1 would equal 7. So that the GCF, or greatest common factor, of 7b minus 7 would in fact be 7. On to number 2. I need to figure out the multiples of 16. I'm going to break them down as far as I possibly can. So if I take 16 and divide it by 2, that is possible. That would get me 2 times 8. I can take 8 and divide by 2, which would get me 2 times 4. Actually, let's do it a little different way so you might be able to see it a little better. I can take 16 and make it 2 times 8. I can take 8 and make it 2 times 4. I can take 4 and make it 2 times 2. All right? So really what I'm going to end up with is 2 times 2 times 2 times 2. Okay? So I'm going to rewrite that now as 2 times 2 times 2 times 2. Now 8 I can split into 2 times 4. I can split 4 into 2 times 2. So really what I end up with 8 is 2 times 2 times 2. So 2 times 2 times 2. Don't forget about your a's. If it is a squared, it means I'm multiplying by a twice. From here, I want to go ahead and circle what they share. They both have a 2. They both have a second 2. They both have a third 2. So how I figure out my GCF is I will take 2 times, so that's these 2's, 2, that would be these 2's, times 2, which would be these 2's. Okay? 2 times 2 times 2 would be 8, so my GCF would be 8. On to number 3. Again, there's only one way to multiply to 7. That would be 7 times 1. Don't forget about my x's. It'd be times x and times x. There's 2 x's there. I need to multiply by x twice. Now, there's also only one way to multiply to 3, and that is 3 times 1. There's a single x, so I'll multiply by x. What do the two pieces of our problem here share? Well, they're just going to share a single x and, well, a 1 as well, right? So it would be 1, which would be these ones, times x, which is here, 1 times x would just equal x, so our GCF is x. Okay? On to number 4. There's only one way to multiply to 3. It's 3 times 1. There's 2 a's, so it would be a times a. Okay? There's a couple ways I could multiply to 6. 6 times 1 is one way, but 6 times 1 really doesn't get me, it doesn't change anything, it doesn't really get me anywhere. So there's another way I could multiply to 6, and that is 3 times 2. There's 5 a's there, so I want to write down all 5 a's. All right? So it is 3 times 2 times a times a times a times a times a. I want to circle what they share. They do share a 3. So I can go up here and write down my 3 times something, right? Well, they share an a, so I could write times a. They share another a, so I could write times a. Is there anything left that they share? There is not. So that is going to be my GCF. 3 times a would be 3a squared, because there's 2 a's there. All right. On to our next section. Factor the following expressions by finding the GCF and then factoring it out. I'll explain what factoring out is in 1 second, but our biggest thing that we're doing here is to find our GCF. 14 I can split into 7 times 2 times c. 7 I can split into 7 times 1. What do they share? It's just that 7. So my GCF is 7. Okay? What I'm going to do now is I'm going to take each piece from our problem and divide it by my GCF. So I'll write my GCF out front. Then I'm going to make a set of parentheses. Okay? I'm going to take this 14 and divide it by 7. So 14 divided by 7 would be 2. Don't forget that there's a c attached to that 14, so it would be 2c. Another way to look at this is what is left from my tree from 14c. Well, it's just 2c. I'm going to keep my sign at this point. What is left from my second tree, or this 7? 7 divided by 7 is 1, or that 1 is just left from the tree. So that is what factoring is. Okay? On to number 6. 12 is 3 times 4. 4 can be divided into 2 times 2. All right? So really what I have here is 3 times 2 times 2, right? 18 can be broken into 9 times 2 times a times a. 9 can be broken into 3 times 3. So what I really have here is 3 times 3 times 2 times a times a. So it'd be 3 times 3, which was my 9, times 2 times a times a. The reason why I'm breaking it down to the smallest possible numbers is that allows me to pull out every little piece that I need, and that way I know my GCF will be correct. So the share a 3, so I can write a 3 up here with the GCF. We've already used that. What else do they share? Well, they share a 2. So I can multiply the 3 times 2. Do they share anything else? No, they don't. I use that 2, right? So my GCF would be 6. Remember, when I find my GCF, I'm going to write it on the outside of the parentheses. My first part of inside the parentheses will just be what is left from our tree, so it'll be 2. I'm going to use my sign that's already up there. What's left from my second tree? It's 3 times a, so that would be 3a squared. All right. On to problem number 7. Now I have a trinomial, okay, that has 3 parts to it. We're going to do the exact same process that we did when we had the binomials in 5 and 6. It's just 3 parts to it now. So 5x squared would be 5 times x times x. 15x would be 3 times 5 times x. And 35 would be 7 times 5. Okay? What? Now I'm looking for what all 3 parts share. So in this case, they all have a 5. That means my GCF will just be that 5. Go ahead and write 5. Parentheses. What's left from my first tree? It would just be x squared. I'm going to keep my sign. What's left from my second tree? 3x. I'm going to keep my sign. What's left from my third tree? Just 7. So that is the fully factored form of that problem. Okay. On to number 8. Here I have 3 times x times x times x. The 6 can be broken into 3 times 2 times x times x. And the 9 can be broken into 3 times 3 times x. They all share a 3. So it'll be 3 times something. I've already used that 3. I can get rid of it. They all share an x. So it would be 3 times x. All right. So my GCF then would be 3 times x, which is just 3x. 3x would go on the outside of my parentheses. In my first part, what's left from my tree be x squared. Second part, what's left in my tree, 2x. What's left in my tree from the third part, just 3. Now I need to figure out my signs. In between my x squared and my x is or 2x is a positive. In between my 2x and my 3 is also a positive. So we are good there. All right. On to number 9. 2x to the fourth. I can split that into 2 times x times x times x times x. 4x to the third can be 2 times x times x times x. 6x squared can be 2 times 3 times x times x. What do all 3 of them share? They share a single 2. So it would be 2 times. They all have at least one x, right? So those x's can go away now. And they all have a second x. So those x's can go away now. What I'm left with is 2x squared. Go ahead and write 2x squared on the outside of my parentheses. What's left from my tree? The first tree is x squared. What's left from my second tree? That's 2x. What's left from my third tree? It's just 3. Now I'm looking for my signs. The first sign I run into is a negative sign. The second sign I run into is a positive sign. So I've shown you a couple different ways of thinking about how to find your signs. Just find something that works for you and everything will work out fine. On to number 10. 8 we've talked about a couple times. That's 2 times 2 times 2. Don't forget your x. And 12 can be broken into 4 times 3. But 4 can be broken into 2 times 2. So I can really write my tree as 2 times 2 times 3. I'm going to circle what we share. They share a 2. I'm going to circle what they share. They share another 2. So really what they share is a 4. When you get really good at this and you start being able to see the different multiples of these numbers, you will not have to make the tree and write a bunch of things in the GCF. You'll just know what the GCF is off the top of your head. Okay? I'm going to put 4 outside the parentheses. What's left from my first tree? Just 2x. What's left from my second tree? Just 3. There's only one sign in this case, and that is a positive. All right. On to number 11. Number 11. Again, I have a trinomial. It would be 5 times x times x. 20 I can split into 4. Oh, that doesn't even look like a 4, does it? I can split into 5 times 4 times x. 4 can be broken into 2 times 2. So in my tree, it would really be 5 times 2 times 2 times x. All right? And 10 I can break into 5 times 2. Again, when I have a trinomial, I'm looking for what they all share. They do share a 5. So I'm going to put 5 up in the GCF. Don't need the 5 anymore. Do they share anything else? All 3 of them must have it in order to say that they share it, in order to be part of the GCF. Well, in this case, I only have x's in this section. I have 2's and x's here, and I only have a 2 there. So they do not all three share anything else. So my GCF in this case is only going to be my 5. I'll put my 5 on the outside of the parentheses. What's left from the first tree? X squared. What's left from the second tree? It would be 2 times 2. Well, 2 times 2 is 4. And an x. What's left from my third tree? It's a 2. Now I'm looking for my first sign is a negative, my second sign is a positive, and that is our factored form. On to number 12. Number 12, I can break 3y to the third up into 3 times y times y times y. 9y squared can be 3 times y times y. And 24 can be 3 times 2. Oh, I'm sorry. It'd really be 3 times 8, right? Well, 8 can be broken into 2 times 2 times 2. So really what that breaks down into is 3 times 2 times 2 times 2. Don't forget about your y, so it's times y. What do all three share? Well, they all three have a number 3, right? So it'll be 3 times. What else do all three of them have? They all three have a y. So my GCF would end up being 3y. Remember, I can get rid of these now. What's left? Now that I know what my GCF is, 3y, put it on the outside of the parentheses. What's left from my first tree? By squared. What's left from my second tree? 3y. What's left from my third tree is 2 times 2 times 2, which is 8. My first sign is a negative, my second sign is a positive, and that is my factored form. Let's go ahead and move on to the back side. Here we're going to solve the following for x. What we're really going to do is we're going to find a GCF first. Okay? So it's the exact same process as what we were just doing on the front. I'm going to take 7 and break it into its parts. So it'll be 7 times x times x. 14x would be 7 times 2 times x. They share a 7. They also share an x. Get rid of that 7 now. Okay? So my GCF would be 7x. So 7x go outside the parentheses. What's left from my first tree? It's just x. What's left from my second tree? It's just 2. The only sign that I have is negative. All of that is still equal to 0. That is really important that you keep it equal to 0, because if I do not have it equal to 0, I won't be able to solve for it. Now that I have two separate pieces, I have the 7x on the outside and the x minus 2 on the inside, what I can do here is split them up and set them both equal to 0. Okay? I would divide by 7, so x would equal 0. I can add 2 to both sides, and x would equal 2. That should be a review for you from Algebra 1 when I have them broken up, how to solve for x. All right. On to number 14. Again, I want to find my GCF. Some of you at this point will probably be able to see what my GCF would be, but I'm going to continue to break them into trees. Be x times x. This would be 5 times x. They share an x. So my GCF in this case is just x. What's left from my first tree? What's left from my second tree? Negative in between. All that would be set equal to 0. Now that I have the two separate pieces, I will take what's outside and set it equal to 0. Take what's inside and set it equal to 0. Need to solve by 5. So x would equal 5. And x would equal 0. Now, I need to rewrite the following in intercept form. We've been working with intercept form quite a bit in the past. What you need to remember about intercept form is it's going to be in 2 sets of parentheses. I would have 2 sets of parentheses. I'm going to have an x in the front and an x in the front. Okay? I'm going to have some number here and some number in the second parenthesis. How I'm going to do this is I want to find out what my GCF is. Okay? That was just an example of what our intercept form is going to be. We'll get back to that in 1 second. So I break up x squared, it would be x times x. If I break up 5x, it would be 5 times x. What do they share? They share an x. So my GCF is x, right? So I want to write it just like I have in the past. X goes in the outside of the parenthesis. What's left is x and 5. The sign was negative. Okay? Now, intercept form, I'm going to have something that goes with this first x. In this case, it would be x plus 0 because there's no other number with it. This would be x minus 5. So now I need to find my x-intercepts. If you remember from intercept form that we've done in the past, I'm going to use the numbers here. I'm going to go opposite the sign. So this would be 0, 0. This would be 5, 0. So my x would equal 0, and my x would equal 5, just like in the previous unit where I was solving by graphing. Compare those to your answers in number 14. They are exactly the same. So both of those processes are exactly the same. All that is doing is really connecting our previous unit to our current unit and showing you how it works together. X-intercepts. This is extremely important. You're going to want to remember these 3 words. Okay? They're all interchangeable. They all mean x-intercepts. They all mean the same thing. Okay? So x-intercepts are also called roots, solutions, or zeros. They are all called the same thing. So x-intercept can also be called roots, can also be called solutions, can also be called zeros. You're going to hear me use those words interchangeably. They all mean exactly the same thing. All right. That is the end of our lesson. The most important part of this lesson was remembering how to find my GCF. Once I do find my GCF, how to factor that out. And then at the end is to be able to solve for x after I have factored out my GCF. Thank you very much for watching this video. Make sure that if you have any questions, you come prepared with those tomorrow. And have a great day.